Hello guys, in this video we are going to discuss the solution of the problem make array elements unique. So let us look at the problem statement. The problem statement says given an array ARR, your task is to find the minimum number of increment operations required to make all the elements of the array unique. That is, no value in the array should occur more than once. In one operation, a value can be incremented by 1 only. So for instance, if this is the array which is given to us, in this array, if we increase the value of this 2 by 1, then the elements of the array become unique, because of which we are returning 1 over here. Similarly, in this array, if we increase the value of this element by 3, then all the elements of the array will become unique, since we are incrementing this value by 3, because of which we are returning 3 over here. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So the general idea behind solving this problem is, the first thing which we have to do is we have to find duplicates. And the best way to find duplicate is by sorting the array. Hence, what we are going to do is we are going to sort the array. Once we have sorted the array, then we are going to check whether an element is a duplicate or not. Once we identify that an element is a duplicate, then we are going to compute the cost or the amount of increment needed over here, and the amount of increment which is needed will be given by this value, which is equals to diff equals to ARRI minus ARRI minus 1, and then we are going to compute the cost, which is equals to cost plus diff plus 1, which is the cumulative cost, or this is our answer, and this is what we are going to return. And in case of duplicate, we are going to update ARRI such that it becomes a unique element. And the way we are going to make it as a unique element is essentially ARRI equals to ARRI plus diff plus 1. So that's the general idea behind solving this problem, folks. Now let us take a couple of examples in order to understand this. So let us say this is the array which is given to us. The first thing which we do is first we are going to sort the array. So the sorted array will look something like this. Once we have sorted the array, then we are going to find the duplicates over here. So when I will be equals to 2 and I is the iterating counter, so I is at the last index over here, then we identify that ARRI is a duplicate. Now since this is a duplicate, what we are going to do is we are going to compute diff. So the diff will be given by ARRI minus 1 minus ARRI. So in this case, diff will be equals to 2 minus 2, which is equals to 0. And once we have computed the diff, the cost will be given by cost plus diff plus 1. So let us plug the values. Initial value of cost is equals to 0, diff is equals to 0, and then 1. So this becomes equals to 1. And then let us update ARRI such that ARRI is unique. So ARRI will be updated as ARRI plus diff plus 1. So this becomes equals to 2 plus 0 plus 1, which is equals to 3. And in this way, we have made all the elements of the array unique, and towards the end, we just have to return the cost. So in this case, we are going to return 1. And in this way, by performing one increment operation, we are able to make all the elements of this array unique. So let us take one more example. Let us say the array which is given to us is this. So the first thing which we are going to do is we are going to sort this array. So the sorted array looks something like this, and then we are going to find the duplicates. So the first duplicate is encountered when I is equals to 1. So for this case, diff will be given by ARRI minus 1 plus ARRI. So over here the diff will be equals to 1 minus 1, which is equals to 0. And the cost will be given by cost plus diff plus 1, which is equals to 0 plus 1, which is equals to 1. And let us update our ARRI. So ARRI, which is equals to 1, becomes equals to 2. Now folks, this array has been manipulated, and now the array looks something like this. Again, when we are at I is equals to 2, we realize that this is a duplicate. I is equals to 2 is this element, and this element becomes duplicate. Now since this element is a duplicate, again we are going to compute diff and cost. So the diff will be given by 2 minus 2, which is equals to 0, and cost will be equals to cost so far, and the cost so far is 1 plus diff plus 1. So diff is 0 and plus 1. So now the updated cost becomes equals to 2. And let us update our ARR I, and I is equals to 2 over here. So ARR I becomes equals to 2 plus diff plus 1, which is equals to 3. So now the updated array looks something like this. So ARR array, so ARR equals to 1, 2, 3, 3. And now once we have updated this value becomes a duplicate. So when I is equals to 3, this is also a duplicate. So again, we are going to compute diff. So diff will be equals to 3 minus 3, which is equals to 0. Cost will be equals to cost so far, which is equals to 2 plus diff, which is 0 plus 1, which is equals to 3. And ARR I, which is equals to 3, becomes now 3 plus 0 plus 1, which is equals to 4. And now the array ARR gets transformed to 1, 2, 3, 4. And in this way, if you see, we have made all the elements of the array unique, and the cost we have incurred is this cost. So in this case, we are going to return 3. Now let's take one final example, and then we will discuss the pseudocode of this problem. So let us say this is the array which is given to us. So the first thing which we are going to do is we are going to sort this array. So the sorted array will look something like this. And then when I is equals to 4, which is this element, then we realize that it is a duplicate. Since this is a duplicate, we are going to compute cost. So the cost will be given by 6 minus previous element, which is equals to 0. And the cost will be given by diff plus 1, which is equals to 0 plus 1, which is equals to 1. And let us update our ARRI. So ARRI becomes 7. So the updated array looks something like this. Now over here, when I is equals to 7, we realize that the element is a duplicate, and that element is this element. And since this is a duplicate, we are going to compute diff. So the diff will be given by 9 minus 9, which is equals to 0. And the cost will be given by cost so far, which is 1, plus diff plus 1. So the cost will be equals to 2. And the element ARRI equals to 7 becomes equals to 10. So the updated array looks something like this. Now again, when I is equals to 8, which is this element, we realize that this element is a duplicate. Folks, we realize that this element is duplicate is because since the array is sorted and the previous element is greater than the current element, which should not be the case. Since the array is sorted in increasing order, so the previous element should be less than the current element. Since this is not the case, we realize that this is a duplicate. Now since this is a duplicate, we are going to compute our diff and cost. So the diff will be given by 10 minus 9, which is equals to 1. And the cost will be given by cost so far, which is equals to 2, plus diff plus 1, which is equals to 4. And the array and let us update our ARRI. So ARRI, which is equals to 8, becomes equals to 9 plus diff plus 1. So this becomes equals to 11. So the updated array looks something like this. And folks, in this way, we have made all the elements unique, and the cost which we are going to return in this case is 4. So that's the discussion of solution, folks. Now let us discuss the pseudocode of this problem. So let us say we want to find the minimum number of increment and an array is given to us. So the first thing which we are going to do is we are going to sort the array. After sorting the array, let's take our answer, which is equals to 0. And this answer essentially is our cost. And then we are going to iterate on the elements of the array. So for that, for I in a range of 1 to len of array. And folks, please note I am starting from 1 rather than 0. And the reason why we are doing that is because we want to check ARRI minus 1. So since we are operating on I minus 1, because of which I have started from 1. If ARRI minus 1 is greater than or equals to ARRI. And folks, this is the condition to identify whether the current element is a duplicate or not. let us recall from our earlier discussion. So let's look into this case. As you have realized, when we are at this position, we realize that the current element is lesser than the previous element. Since the array is sorted in increasing order, this should never be the case. Since this is happening, because of which we realize that this is a duplicate, because of which we are relying on this condition in order to find the duplicate, which is the previous element. If it is greater than or equals to the current element, then this is a duplicate. Once we have realized that this is a duplicate, then we are going to compute our diff and cost. So the diff will be given by ARR I minus 1 minus ARR I, and the cost, in this case answer, will be given by answer plus diff plus 1, and let us update our ARR I. So ARR I will be equals to ARR I plus diff plus 1, and towards the end we just have to return answer. So that's the pseudocode, folks. Now let us see how we have implemented this in Python and C++. So first let us look at the Python implementation. So over here we are first sorting the array answer equals to 0, and then we are iterating on the elements of the array. If this is a duplicate, then diff and answer will be computed and array and ARRI will be incremented, and towards the end we are returning answer. So that's the Python implementation, folks. Now let us submit our solution. So our Python solution got accepted. Now let us look at the C++ implementation. So the C++ implementation is also the same, folks. Answer equals to 0, and then we are sorting the array. We are iterating on the elements of the array, and we are identifying whether this is a duplicate. If this is a duplicate, then diff will be computed, answer will be updated, and ARRI will also be updated. And towards the end, we are returning answer. So that's the C++ implementation, folks. Now let us submit our solution. So our C++ implementation also got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.